In this video, I am going to work out some problem for chapter 2, motion in one dimension. So here we have 8 questions and we are going to answer one by one. What is given in the first question? A toy car moves in the path as shown in the graph. So the graph is given, and in y-axis we have the distance, and in x-axis we have the time. And what we are going to find? We are going to find the average speed as well as the average velocity of the car in the time interval from 2 to 10 seconds. So here we have the time interval in x-axis and we have the distance, that means the path covered by the toy car is given in y-axis. And we have to apply the rule, and we already studied the average speed formula. What's the formula for the average speed? The average speed is exactly equal to distance covered over time. Distance covered over time. Now we have to find what is the distance. When time is equal to 2 seconds, the toy car covered the distance of 4. At time is equal to 4 seconds, it has 0 value. At time is equal to 6 seconds, it has -2, but we are going to consider only the magnitude. And for 8 seconds, again, its distance is 2. For 10 seconds, again, the distance is 0. So what I am going to do, I'm going to add all the distance value for its corresponding time. So for 2 seconds, the distance is 4. For 4 seconds, the distance is 0. For 6 seconds, the distance is 2. For 8 seconds, the distance is 2. And for 10 seconds, the distance is 0. Divided by the total time is between these is 10 minus 2. So I'm going to write directly 10 minus 2, and if you calculate 4 plus 2 plus 2 gives you 8, and in the denominator also you have 10 minus 2, which is 8. The answer is 1 meter per second. This is the answer for average speed. And we know the formula for the average velocity also. So average velocity which is equal to the displacement over change in time. And we know the formula for the displacement: final position minus initial position. So here the final position here as 0 and the initial position is 4. So that means the final position is 0, initial position is 4. So 0 minus 4 divided by the final time is t. The t is equal to 10 seconds and the initial time is t is equal to 2 seconds. So 10 minus 2. So the answer is minus 4 over 8, which gives you the value of half. So the value is minus 0.5 meter per second. This is the answer for the first part. And what's the answer for the second part? Find the instantaneous velocity of the car at t is equal to 4 seconds. And we know the formula for the instantaneous velocity, which is equal to v, which is equal to dx over dt. But here we have the graph, so I'm going to calculate the time parameter as well as the x parameter. That means the distance as well as the time. So I'm going to take the slope of this line. You can choose any 2 points from this line. So better I'm going to take the highest as well as the lowest value here. And I'm going to write the formula, the instantaneous velocity, which is equal to dx over dt. So better I'm going to write delta x over delta t, because we are going to find the slope. So delta x value is final position. The final value here is minus 2, and here this one is no, the value is 4, sorry, because this is the value of x2 comma y2. So the value here is 4 minus of 2, clear, divided by, and the time value is, this is your y2 value and this is your x2 value. So the value is 2 minus 5. So the answer here is 4 minus of minus 2 is 6 divided by 2 minus 5 is minus 3, and we know the value. So when you divide this 3 for 2, you will get minus 2 meter per second. So this is the answer for the second part. Now we have to move to the second question. In second question, again the graph is given, so we have to read a word by word. In second question, we are going to find the velocity of the motorcycle as a function of time is shown in the graph. So if you see the graph, x-axis they have the time parameter, in y-axis they have velocity. Find the average acceleration from t is equal to 0 second to t is equal to 10 second. Also find the instantaneous acceleration of the motorcycle at time t is equal to 2 seconds and time t is equal to 12 seconds. So we are going to answer one by one because this question has 3 subdivisions. First, we are going to find the average acceleration. And we know the average acceleration formula. What's the formula for average acceleration? Average acceleration, which is exactly equal to change in velocity over change in time. And they mention the time start from 0 to 10 seconds. So you have to consider from 0 to 10 seconds only. And here we know the formula for delta V, that is V final minus V initial over T final over T initial. So what is the V final here? The V final here is 45 at time t is equal to 10 second. So for 10 second, what is the final velocity? The final velocity is 45. And what is the initial velocity? Because we are going to calculate from 0. So what's the initial velocity? 20. So 45 minus 20 divided by the final time is 10, the initial time is 0. So 10 minus 0, which gives you the value of 45 minus 20 gives you the value of 25, and 10 minus 0 is 10. So 25 divided by 10 gives you the value of 2.5 meter per second square. So we have completed the first part, and in the second part we are going to find the instantaneous acceleration for two time value. For t is equal to 2 seconds, what is the value of instantaneous acceleration? For t is equal to 12 seconds, what is its value? So we know the formula. The formula is dv over dt. So the graph is given. So I'm going to calculate the slope value. For second part, the formula, the instantaneous acceleration, it's dv over dt. I'm writing here delta v over delta t because it's a slope value, which is equal to, for t is equal to, better I can just write the time here, time t is equal to 2 seconds. For time t is equal to 2 seconds, you have to see here, the time to here is 20, am I right? And also from here to here, at the time t is equal to 2 seconds, you can just see the line. If you just have a straight line, what is the slope value? That is, you cannot be able to find the slope. So answer exactly 0, because for the horizontal line, you cannot be able to find the slope. So the answer for t is equal to 2 seconds is 0. And the answer for the second part, at a time t is equal to 12 seconds, we have a straight line, because you can just see here, for 12, we have this straight line. You can choose any 2 points, and better I can just take the highest as the lowest value. So if you take the highest value, the a value is again delta v, the slope, over delta t. So I'm going to take the highest value. So 45 minus 0 divided by 10 minus 14. Clear? So the answer is 45 over minus 4, which gives you the value of minus 11.25 meter per second square. So this is the answer for the second question. Now we have to move to the third question, and third questions it's related with the equation of the motion with constant acceleration. So you have to identify each and every value very carefully. So first of all, we are going to read the questions word by word. A small plane landed on a runway with a velocity of 15 meters per second. So that means its initial velocity is given. What's the initial velocity here? The initial velocity is 15 meter per second. And then it comes to rest. So when any object comes to rest, what is its final velocity? It's 0 meter per second. And for covering this, it takes the time. That means from 15 meter per second to 0, it takes the time value of 5 seconds. Find the magnitude of the acceleration. So what should be the acceleration here? Actually, it is a deceleration, because initially the speed is more and the final speed comes to 0. So that means its acceleration is going to decrease. So we have three equations, the three main, actually we have 5 equations. You can choose the perfect equation for getting the answer. So here I'm going to use the equation of V, which is equal to V naught, that means V final, which is equal to V initial plus A multiplied by time. This is the first equation, am I right? So by using this equation, I'm going to find its deceleration value. That means here the acceleration value will comes in negative. So if any value of the acceleration is negative, then it's exactly says the deceleration. So I'm going to rearrange this equation AT, which is equal to, I'm going to move the V initial to the left hand side. So it becomes V final minus V initial, and therefore therefore acceleration, which is equal to V final minus V initial divided by time, and we have the value of V final is 0, V final is 0, minus V initial is 15, and the time is 5 seconds. So minus 15 divided by 5 gives you the value of minus 3 meter per second square. So this is the answer for the third question. For fourth question, a driver started his car from rest. That means what is the initial velocity? The initial velocity, which is exactly 0 meter per second, and accelerated it uniformly to cover the distance of 50 kilometer in 5 seconds. So it covers the distance of 50 kilometer in 5 seconds. So initially the car is at rest, and after that it is accelerated, and by that acceleration it covers the distance, the total displacement from 0 to the final position is the displacement. So better I am going to write its delta x value as 50 kilometer. So better we can convert this kilometer in terms of meter. So we know 50 kilometer multiplied by, in 1 kilometer we have 1000 meter. So I can cancel this kilometer with kilometer. So finally I will get 5000 meter. That means the total distance covered. There's a displacement, am I right? And for covering this much of distance, how much time it takes? It takes the time value of 5 seconds. So again we are going to deal with the acceleration. So here we have 3 equations. You can choose the correct equations. So for what I'm going to do, first of all, I'm going to use the third equation. So what is our third equation? V final square. No, I think it's not possible. Better I'm going to pick the second equation. The second equation is x final minus x initial, which is equal to the initial velocity multiplied by time plus half AT square. and here x final minus x initial is our delta x value, and here v initial is 0, anything multiplied by 0 because we have the time 5, but what is our initial velocity? Our initial velocity is 0, so anything multiplied by 0 is 0 plus half at square, and we are going to find the acceleration, so you have to rearrange this equation. So acceleration multiplied by time square, which is equal to 2 multiply of delta x, and therefore acceleration, which is equal to 2 multiplied by delta x divided by time square. I'm going to substitute the value. 2 multiplied by my delta x value is 5000 divided by my time square is 5 square, that means 25. So if you calculate, you'll get the answer of, I think so, here it is 10,000. 10,000 divided by 25 is exactly 10,000 divided by 25 gives you 10,000 or 2 multiplied by, sorry, here 50,000. Maybe I made some mistake here, because 50 multiplied by 1000, it's a 50,000, so I have to include one more zero. So 50,000 multiplied by 2 divided by 25 is 4,000 meter per second square. This is the answer for the fourth question. Fifth question. What is given in the fifth question? A speedboat, which is nothing but the sailboat, increases its speed uniformly from 20 meter per second to 30 meter per second. So here they give the value of initial speed, which is 20 meter per second, and its final speed is 30 meter per second, and it's covered the distance of 200 meter, and for covering this 200 meter with its 20 meter per second as initial and final 30 meter per second, how much time it takes? So what I'm going to do for answering this question, I'm going to make two steps. In the first steps, I'm going to find the acceleration, because without acceleration it is not possible. So I'm going to make two steps. In step 1, I'm going to find the acceleration. So we are going to use the third equation, v square, that means v final square, which is equal to v initial square plus 2 into a into delta x. I'm going to rearrange this equation directly. So acceleration, which is exactly equal to v final square minus v initial square divided by 2 multiplied by delta x. I'm going to substitute the value for v final and v initial. V final is 30 square and v initial is 20 square divided by 2 multiplied by 200. So let's see what is the answer. 30 square minus 20 square divided by 2 multiplied by 200. So the answer is 1.25 meter per second square. What's the acceleration? 1.25 meter per second square. This is the answer. And after I find the acceleration, I'm going to find what's the time. So we have the first equation. So for step 2, what I'm going to do? For step 2, what I'm going to do? I'm going to use the first equation. V final, which is equal to V initial plus acceleration multiplied by t. So acceleration, I'm going to take the value of acceleration from the first part, and I'm going to rearrange this equation in terms of t. So what I will get? T, which is equal to v final minus v initial divided by acceleration. So I'm going to substitute the value. So if you substitute the value, what you will get? T, which is equal to my final velocity is 30 minus initial velocity 20 divided by my acceleration is 1.25. So I'm going to substitute the value in my calculator. So 30 minus 20 divided by 1.25 gives you the value of 8 seconds. So how much time this sailboat takes from the initial speed to the final speed, it exactly takes the second of t, which is equal to 8 seconds. So this is the answer. And now we have to answer the sixth question. What is given here? A football is dropped from the top of the Burj Khalifa. It takes 2 minutes to reach the ground. And what is the velocity of the football just before it strikes the ground? And here, of course, because the ball is in the air, so we have to take the acceleration due to gravity value is the negative value. So what I'm going to do, I'm going to pick the first equation. I'm going to modify that equation for free fall because this question is completely related to free fall. So we know the equation V final, which is equal to V initial plus acceleration multiplied by t, and this question is related with the free fall. So what I'm going to do, I'm going to rearrange this equation. So I'm going to reform the equation in terms of the free fall. So V final, which is equal to V initial, our acceleration is negative value. So better I'm going to change the sign here, minus gt. What we are going to do, we are going to find what is its initial, sorry, what is its final velocity. So when you drop the ball from the top of the Burj Khalifa, what is its initial speed? Its initial velocity is 0 meter per second. And the acceleration is the free fall acceleration. So we are going to substitute the value of the g here. So I'm going to substitute the value here. V initial is 0. And then I already changed the sign here. So I no need to put again the negative here because I already changed the sign in the equation. So 0 minus 9.8, and how much time? The time is 2 seconds. In 2 seconds, in 2 minutes, how many seconds are there? In 1 minute, we have 60 seconds. For 2 minutes, it is 120 seconds. So 9.8 multiplied by 120 seconds. So here the initial speed, sorry, final speed, which is exactly equal to negative of minus 9.8 multiplied by 120, 1176. So minus 1176 meter per second. So this is the answer for the sixth question. So we have to move to the seventh question. So the seventh question is given here. So what is given in the seventh question? It's related with a bullet, which is fired from the gun. When you're just triggering the gun, the bullet is coming out of the gun. So the question is related to the bullet. A bullet is fired vertically upward. So that means you are just firing the gun in the upward direction. And initially it is moved the speed of velocity of 10 meter per second, and find the maximum height at which the bullet will reach. And here the time is not given, and here the bullet is in the air, so its acceleration is negative value, and we have 5 equations of motions with constant acceleration. So which one is convenient for you, you can just pick it. And now what I'm going to do for solving this question, I am going to choose the third equation. So better we just write what is given in the question. Initial velocity is given, am I right? So initial velocity here is 10 meter per second. And what's the value of g? 9.8. And what is the final velocity? We are going to find no, because when the bullet reaches the maximum height, its final velocity becomes 0 meter per second. So I'm going to use the third equations, which is V final square, which is equal to V initial square minus 2 into G into delta Y. So why I just write delta Y? Because I'm going to consider the equation with respect to Y axis. So I have to find what is the value of delta Y. So here the delta Y is exactly equal to the height. So if you modify the equation, V final square, which is equal to V initial square minus 2 into G into height. So we are going to find the value of height. So I'm going to move this minus 2GH to the left hand side, and I'm going to move this V final square to the right hand side. By that your equation becomes 2GH which is equal to V initial square minus V final square, and H, which is equal to V initial square minus V final square divided by 2 multiplied by G, and I am going to substitute. Brother, you have to listen carefully. Here the value of the G is negative, but already when I just write the equation, I put minus. So no need to put minus again here, otherwise the answer will be, it's different. Different means so you will get the answer in terms of negative. So I already make the equation in terms of negative, so no need to substitute the G value again negative, okay? So now I'm going to substitute the value. So V initial here is 10 meter, that means 10 square minus 0 square divided by 2 multiplied by 9.8. So what's the answer? 10 square minus 0 divided by 2 multiplied by 9.8, it gave 5.10 meter. So what's the height? 5.10 meter. This is the answer. That's it. Now we have to answer for the fill in the blanks. What is given here? We have 3 questions. We have to give the answer one by one. The rate of change in displacement of an object moving along one direction is known as, because rate of change, it's related with the velocity, and they give the displacement. You should not write the speed, okay? So the rate of change of displacement, because we know V, which is equal to displacement over time. So the rate of change in displacement gives you velocity. What's the answer? Velocity. For the second question, in velocity versus time graph, the instantaneous acceleration of an object at a given time is equal to the slope of the tangent line. For example, if you have the curve, you have to draw a tangent line, and for the tangent line, you have to find the slope. We already studied these things in the theory class. Am I right? So in the third question, when air resistance is negligible, a different object dropped under the influence of the gravity near Earth's surface fall towards the Earth with the same acceleration. So what's the value? So it has the same acceleration value. Now we have to answer the ninth question. It's match the following. So we have to connect the correct answers. First question, SI unit of the acceleration. So what's the SI unit of the acceleration? We know acceleration, which is equal to change in velocity over change in time. And we know what's the unit for the velocity? It's a meter per second. And already one more second here for the unit of the time is second. So the answer is meter per second square. So I have to connect acceleration with meter per second square. And what's the speed? What's the speed? Because here we have two things, and here we have meter per second. So velocity also have the unit meter per second, speed also have the unit meter per second, but the question is match the following. So you have to search for the another answer for the second question. So the speed, here the speed is the scalar quantity. The speed only gives you the magnitude. So I'm going to connect the speed with the scalar quantity because the speed gives you only the magnitude. The third question, it's a displacement. Displacement, it's a vector quantity. It gives both magnitude as well as the direction because the chapter is related with motion of an object in one dimension. So if you consider one dimension, sometimes the object might be moves in positive direction or negative direction. So here the displacement gives you the vector value. That means it's a vector which gives you the value of magnitude as well as the direction. And the last question, the unit of velocity, SI unit. So the velocity unit is displacement over time. The displacement unit is meter and the time unit is second. So the answer for the fourth question is meter per second. That's it. So listen carefully. If you like this video, please kindly subscribe my video, and if you have any doubts, you can just feel free to communicate me through the comments, and please kindly share this link to your friends. by that they also get some idea. Okay, so please kindly subscribe and kindly like this video and please share this video link. Thank you so much.